Hi guys, this is AP Calculus ABA, the ABA without the extra B, and we're finding limits graphically and numerically, and this is a 2.1 in your book. Okay, so 2.1, you do need to know how to calculate slope. Why? Because of the secant line problem and that leads into the tangent line problem. Okay, so what you guys are going to be looking at is approaching a number. Okay, so the definition of a limit is hugely important. So when you're asked the limit, when you're asked for the limit, you need to be sure that you have a good idea of what's going on. Okay, so let me highlight what I want to copy. Okay. All right. Let's go enter. Okay, so this is straight from the babe's mouth. As x approaches the value c from either side of c, f of x becomes arbitrarily close to single value L. It's just like the secant line problem. We got closer and closer to Q, point Q. The limit as x approaches c is L. When you're asked to find the value of a limit, the answer is the y value as x approaches c. Arrow pointing right. Oh, geez. What is this? Ignore this part. Okay, we're going to have to focus on three things. Okay, we're going to approach x from both sides. Three methods for finding limits and when limits do not exist. So let's go straight to the graph. Let's go to Desmos. Okay, now the best way to really talk about this is to talk about a rational function in the beginning. So y equals x minus 4 divided by x squared minus 16. There we go. Okay, so now normally the rational function would look like this. It would be just in its rationality, just looking like this. Okay, however, my asymptote would be at -4 according to this, but I'm also looking at it and going, what about my asymptote at 4? Where is that? Okay, now no matter how I approach 4, okay, if I click on the mouse and move it close to 4, okay, I'm going to get really close, and I can see I'm approaching almost 0. I'm almost stopping, or 1/4 or an eighth. And then, oh my gosh, all of a sudden I get to 4, I get undefined. Okay, so what the heck happened? Okay, now if I approach from the other side, and this is called a right-handed limit, all right, I'm approaching a quarter or an eighth, which is 0.125. Okay, I keep going, I get closer, and I get closer, and then I get undefined again. I get to a hole. Okay, so we're not looking at the exact value of what y is when x is 4, but we're looking at the limit. Okay, so how that's usually said is the limit as x approaches 4 for this function, let's call this f of x, is 0.125. Okay, and that's how I would say it. And let's go back and actually call this f of x. There we go. So that makes it all nice. So the limit as x approaches 4 for f of x is called 0.0125. Now they have it in the book, or what they will have in the book is written out as you will have the limit right here, and then right below it you'll have x approaches 4. It'll look like this, and then you'll have f of x, and I'm not going to write that whole thing, and it will actually be about, you could say 1/8, you could say 0.125, it's totally up to you how you want to say it. Okay, but you're actually going to approach a number, so you're going to get close to a number that doesn't exist, but it might exist, it probably does exist, but sometimes if it doesn't, we're going to talk about the limit as it approaches it. Okay, so that's from the left side and the right side, and you could actually say that, okay, as you work with it. And there's some definitions. Definition of a limit, okay, and it is in actuality if if you can plug in a number, I mean, you could just work with it. I mean, there's just a lot of stuff in there. The definitional limits are huge, so please work with them. You can do the sum of two limits. You can do the difference of two limits. Hold on, let me change that. You can do the product of two limits. You can multiply a limit by a constant. However, quotient of a limit, the bottom part of the limit must not, the bottom part of the denominator of the quotient must not be 0, or the limit must not be approaching 0. And the power rule is if you're raising something to a power with an r to the r divided by s, the limit is the same as the power. The limit to that power is going to be the same answer. Okay, so I mean, there's a lot of interesting stuff that just work with it. So as you're working through this, make sure you go to Khan Academy and check out those videos that definitely talk about limits. I mean, those are some more, those are a little bit more helpful in their, well, they're a little bit more diverse than what's given here. So in other words, we just kind of talk about everything in one fell swoop, whereas in Khan Academy they talk about it in a whole bunch of videos that just show up. The main thing I want you guys to be able to do is to approach x from both sides, okay? And then 3 methods for finding limits is what we'll be working with. One is just straight up finding the limit. Second is doing it graphically. And the third one is analytically, because there's a whole analytical mess that just comes up. Okay, one-sided and two-sided limits are just huge to work with. Sandwich rule, if you cannot find a limit directly, you may be able to find it indirectly just by taking a look at it. And I mean graphically, if you really are having a tough time, find it graphically and just work with it that way. Okay, like for example, that analytical one. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, yep. Okay, so this actual one that we just worked with, let's say we wanted to find it algebraically. It was x minus 4 on top. Okay, and on the bottom we had x squared minus 16. Now normally what you could do is you could plug in, if you're finding the limit as it approaches 4, you could plug it in and get the value. But if we plug in 4 here and up top, we are going to get 0 over 0, which is an issue. Okay? When we looked at the graph, we got an actual value, so that's a huge issue. Okay, so what you need to do is you need to go back and you need to actually factor and simplify this so that you can actually find it analytically. Okay, so we have an x minus 4 on top. Okay, now if we work on the bottom, we're going to have an x minus 4 and an x plus 4. Okay, and that's going to be on the bottom. Okay, these two are going to simplify into 1s. Okay, and what I have left is 1 on top and x minus 4 on the bottom. Okay, and now what I can do, well, not x minus 4, geez, I crossed out the wrong x. This should be x plus 4. I crossed out the wrong one. Okay, now what I can do is I can take that value of 4 and plug it into here and go 4 plus 4. And that gives me the 1/8. Okay, so just taking a look at the limits that way, it's just hugely important that you're able to plug it in and just work with it. Now limits that do not exist, you're going to have discontinuous type of limits, discontinuity, those things pop up quite a bit. If you have to use the sandwich theorem, then use it. I mean, it's one of many tools that you can use to get through this. So, you know, it's an amazing process, this limits, just working with it and just actually approaching it. Okay, you can also do by looking at tables, you can plug in values, you can look at the graph. Those are the 3 methods for finding limits. When limits do not exist, or discontinuities or point discontinuities, or just a sharp corners, like I talked about before, is when we're looking at a continuous graph, we want something that doesn't have sharp corners, that has nice smooth corners. Alright, that's it for finding limits graphically and numerically. If you have any other questions, please feel free to contact me. Otherwise, I'll see you guys on Thursdays. Bye.